Check first. Do you hear me okay? Yeah? The guy in the back too. Yeah. So I'll start. Last speaker of a long week, and I changed the title of my talk because I'm just about to try to define if I am doing engineering systems rather than systems engineering. Am I working with engineering systems rather than technical, complex or cyber-physical systems? I have a mechanical engineering background here from KTH, and I also had an early interest of space programs, and I thought I was going to work in space engineering somehow. But I found a PhD position, the first at KTH, in human-machine system, which was designing technology, but with human as one of the components and needing human knowledge requirements to design the systems. So I ended up, previous speaker was from NASA. I was at NASA Ames for 1 year, and I was working on warning systems and warning auditory alerts. So that was still technology development for improving safety. But after that, I had my method for designing auditory alerts, and I had a slurp. It was what became known after my PhD. It was a slurping sound for low fuel. That was what all the users and pilots trying it out liked best from my design. It's still in a future cockpit design somewhere in a basement at NASA Ames. But I went to the airlines and I asked them if they were interested in learning about my methods to design cockpits and so on. And that's how my system perspective was very different from today. Because they told me that it's really good that people are working on new technology, but here, within the airline, we have to manage the shit we got. So they had to manage the risk with aircrafts that were not new, not with the hottest and absolute newest technology, and so on. And I also learned that probably my sound and my method, it would take about 15 years before it got certified and introduced to the market and so on. So I chose another path and went into management of safety within air transportation systems. But also within there, I meet engineers. I think that you are more representative of that group that are very much in the beginning of the life cycle of safety in complex socio-technical systems. Because you design the systems that will be used. You design the stuff that will create risks that airlines and operators or users have to manage. So with other colleagues, Martin's colleague Fredrik Asplund, we have compared a lot about how to acknowledge flying an aircraft and operating an airline with designing technology and managing work that you are doing from a management perspective. And we find a lot of similarities. So this is absolutely not presenting new things, but I find it relevant to discuss safety management because you will all come to a company and work within the structure with conditions set for you to do safe and reliable work. So the assurance of system safety, what you need to, the functionalities that needs to be in place is that you need to have ways to identify risk and needs for improvement. Is it on the aircraft? Is it on procedures? Is it on training of pilots or whatever? And you have to be responsive to the indications or signals that you can collect for the relevant process that you are having the process of interest. And then, of course, you need to be able to improve what have been identified as being not fully functioning. But when you do this, you have to also assure that this change actually was implemented and had the intended effect. And as all good engineering, you also have to assure that that change did not introduce new, unanticipated risk elsewhere. And with these very simple principles, simple in words, you may increase the system safety in socio-technical systems where humans and technology interact. So as I said, my main field of expertise has been within aviation and safety. And I guess if I was to, my core focus was to save lives, I would work in another industry because safety is highly reliable today. As a comparison, we have road traffic where 3,000 fatalities happens per day around the world. And we have just had a year within the aviation, 2017, with 0 casualties across the world for the whole year. A colleague at MIT, Barnett, he do statistical analysis and make it up to more simple quotes. So he had concluded that an American kid at a US airport today is more likely to grow up to be the president than to perish in an accident on her next jet flight. As a, just a thought example of how safe it is to travel by air. This was 2008, and it had more impact before Trump. Not to everyone, it seems like it is impossible to become the American president anymore. We have done research since 2005, and I've been working closely with a group at Trinity College. And they have a Center for Innovative Human Systems, and they are at the School of Psychology. So we are merging engineering with psychology. And we have had one project, human integration into the life cycle of aviation systems, where we were, I think, 28 different countries with 40 partners. It was probably the largest human factors project in the world, and especially in the European programs. In this, we had airline manufacturers, aircraft manufacturers, we had service providers of airports, air traffic controller and airlines, we had tech developers and so on and so on. And we were working mainly with identifying where do we introduce risk. We have had the 2 cases now with the Boeing MAX 8, and somewhere these risks were built in and very, very difficult to use as signals to improve something when they haven't been identified. And then we had said that even if you identify these things, we realized that very few organizations still know how to act on things they find not working fully functionally. So we had one full project on managing system change in aviation and how identifying what are the social processes between people, groups, organizations that needs to be in place in order for things to actually happen and improve. And then we had Prospero, which was more on a system of systems level, where we wanted to see how, because airlines or aviation is so reliable, it is very difficult for one single organization to act because they don't have any risk data. They have a lot of data, but not incidents or events that they could use for signals identifying what they need to improve. So we wanted to create a risk intelligence among airlines, airports, air traffic controller, because only by aggregating data from everyone in the system we could find knowledge about the shared system risk. This was a flawed project in many ways, and mostly because we had managers and owners or stakeholders that did not want to share the data because it was competitive, it was operational data they didn't want anyone else to see. So it hindered the safety improvement of the aviation system. But we studied that instead. So again, we focused on the social processes that were not there to support safety improvement. So that has been the core to almost identify a theoretical framework for the human and social processes necessary to act on safety in complex socio-technical systems. So the socio-technical system is the system in focus. And there is difficulties in the science of human factors, which is the collective name. But we do have this assumption that there is a relation exists between the humans and technology when they interact, and that's pretty undisputable. And this interaction affects the overall system performance. And we can't prove necessarily, but the assumption is that undesired system performances when humans interact with technology results from the lack of human factors integration in the system design. If there's, of course, not a malfunction of the technology itself. Relations and dependencies between system components may not be possible to validate, but they are at least verifiable. We can't really measure an interface and say this is safe, because it depends on what you just had a workshop on, all these barriers and, what was the other one? Controls. So we can only look at the outcome still. It's not that we are not trying to be proactive and predictive. We can be predictive by knowing what makes the system function well and so on. In this type of systems, we realize it is a cross-disciplinary field. So human factors engineering in itself is integrating psychology with engineering principles. And the system is both the human, technology, and the organization. And then we rely a lot on system theory, and there are many similarities to systems engineering of technical systems when it comes to theory, method, and tools for managing complexities in design. But then the field of industrial management is not necessarily so common in engineering educations and so on. And this is the control or the management system for safety work. So today I'm not necessarily talking about the pilots flying. It could also be you working on developing something that you are not at harm at your desk, but along the line in the life cycle of the technology, compliance of regulations, compliance of standards, who is managing the changes of procedures or standards within your organization so that you are updated, that everyone knows that people are compliant to the things they do. They do have the safety assurance principles clear. But it is the management of organizations with safety critical operations. But again, then also for those developing and producing safety critical technologies. So these are 3 examples of where we have seen actually Hollywood doing their best to show the human factors at the movies. The China syndrome, you are way too young you might recognize Jane Fonda and Michael Douglas. I think Jack Lemmon is no longer with us. And I'm sure that you have heard of the latest HBO series on Chernobyl, which is another. So these are safety critical systems we have platforms, oil rigs, as in the Deepwater Horizon case. We have aircraft landing on Hudson, and we have system safety in nuclear technology. So, so safety can manifest itself in many ways, and the reasons behind when accidents occur are as complex as the systems, both managing and developing them. How many have had courses in human factors or human-computer interaction? Yeah. So then this is not just repeating your introductory course in human factors. You can look at human factors or ergonomics, they're synonymous, but for some reason ergonomics is more seen as when tools or technology that we use are fit to our bodies, or they fit to our hand. Whereas human factors commonly are more used when it comes to cognitive engineering, when you want things to fit to your brain and your thinking and your decision making and so on. So if you take the engineering principles and practices and you combine it with psychology and behavior knowledge, human knowledge, that's how the human factors and ergonomics field grew. Some of the best engineering colleagues I have are psychologists, so we have a common interest in making things work. The idea is that this knowledge, this integrated knowledge, will feed in to both management of operations and organizations and technology, and to the development of technology so that it will fit humans and operating in safety critical systems. This was probably true, but we see now that there's still so much bad design going on. That is, after 30 years in this field, it's very disappointing. So we see that human factors is not necessarily an integrated part, but it's bypassed. Engineers know what they know, and it's the more complicated and complex cyber-physical systems and other are getting, there's less room for also taking on another field in order to make sure that the technology is fit for purpose and the designs. Similarly, a lot of management is based almost only on psychology and behavior or motivational theories, without realizing that the people that you are managing are working in a highly technology-intensive context, so that the managers needs to understand the relations between technology and humans. So in a way, human factors is getting ignored, but the worst thing might be that there is a lack of focus on work, probably because it's very difficult to do research in situ or in the reality and actually improve things in reality. And it's often due to many of these social processes that you don't get the funds, it takes too long time. When are you going to measure or validate that the improvements you did in a workplace or processes or procedures or for your engineering work, were they implemented? There's a whole research field on implementation and change. But so we are trying to address the gaps in this in our work. So this is not new. We have cared about safety, and we have cared, and human factors has been an integrated part of safety work from the dawn of. This is an example from the aviation. But it very much went from developing the best aircrafts and engines and preventing them from falling off or cracking or anything. So the technical factors were the #1 cause of accidents. So the focus was to develop risk analysis methods and safety engineering to the very technology field. Then when things were working fine mostly, we had a race of aviation safety issues related to the integrated work between the operator and its technology. And that's also the rise of the human factors scientific community. Within human factors, if you broaden the system boundary again, after coming to grips that it wasn't usually only the operator's error, because it was bad design. It was bad design of the technology, and hence you couldn't assume that the user would use it the way the engineer intended, because they didn't have the human factors necessarily background, so it was not fit for the human. So the organizational factors came into use, and that's where resources for training engineers in human factors, resources for safety departments to what we just saw with safety cases and so on, working actively with safety in your operations in a systematic way, grew with organizations. So here's where we started to do safety management. And then now, with the work that you have been doing all week, we see that safety is an emergent phenomenon. It comes from interrelated dependencies between various system actors in a very complex system, and we have the humans, so it's a complex socio-technical system. We are moving into an era of large technical system change that is almost at a societal level. Because even if we see this, and you have probably discussed it during the week, one extreme is the growing field now of ethics in artificial intelligence, because there is it's one thing to design an algorithm, but where does that go when it's globally implemented and it affects the unintended effects of a design of a technology system is growing so rapidly that we don't know how to mitigate the risk fully. Another way of looking at it is to look at various system boundaries that includes various system levels. This is to look at the large technical system levels, where you would actually say that you have some kind of government on the top, where underneath those regulators and associations are doing their best to make sure that there are rigorous ways of complying to laws, and the regulators also assure that people that are certified to act in an area or have airline operation certificate, for example, or you will work in companies that have certified standards that they have to follow. So compliance of how companies are following regulations, and then within the company you have the management that needs to have processes and resources and who is responsible for what in place enough to guarantee that this follows through all the way down. And then you have staff and individuals, meaning yourself or operators, that has to have the trust of their management to believe that this seems to be a good way of working, or here there is no say because this is regulatory, so we do that. But there is enormous amount of challenges coming also from the behavioral and motivational theories of how you have people behave or act in a desired way. Do they find that their work is making sense? Is this principle of design and safety assurance necessary? Do they understand where this is going further down the life cycle? We had a case at the new hospital here in Stockholm. It's very huge and expensive, and they want to have the absolute latest technology. So in a child care unit, they had replaced, you know how it looks like in care units, you have the red and green button for alarming staff or personnel. Instead of that, they have put in an iPad. And in a situation where they needed to alarm, and this is a child care unit, I would be, as an interface designer, I would think, what does an iPad do to a kid today? And they don't let it be. But anyway, the nurses went there to alarm, and they pressed the button on the iPad, and nothing happened. And the common practice is that if you press the red button a long time, the emergency team comes. It triggers the big alarm. So they pressed, and nothing happened. So they went out in the hallway and they called, shouting, and at the same time as the emergency team arrives, also the IT team arrived, being furious about who shut the iPad down and who shut all the 48 iPads down on the ward. And they came to the operators and they said, that's not how you do it. You do like this on an iPad and it lights up. So again, 30 years after I started, you still blame the user for not using it correctly. And regulatory and compliance, they probably just promised what they had in the handbook and the system requirements. So the flaw was probably not necessarily the engineers, but who negotiated, who bought what. Did they know what they need? Did the managers buying these things understand what it was going to be used for? Had they even talked to the nurses about, was it a good idea to use an iPad? Okay, so they lit it up, and instead of 2 options, they had 5 options. And they were in names and concepts that were not known to the personnel. So this is what we don't want to see anymore. It's a little bit it's a lot disappointing. But then when they start questioning it, some people asked also, can you have rubber gloves using that? What if I'm in a child care, intensive care unit? Things are common here to be wet, blood, urine, vomit. Can I use it then? So it started raising questions. But that is too late. That should have been dealt with. And I'm sure that the barriers and controls and safety cases is a perfect tool to do things right. At this level, we can also decompose into a work system. And that's where management comes in also. You will be an employee somewhere. You will have your own qualities and abilities. There will be a particular character of the work you're doing. You will have more or less fit for purpose tools and equipment, competence, training to do what you're asked to do. Information about the regulations and standards and processes. You will be in a physical environment where you are suffocating or where you have fresh air, where it's hot, where it's cold. And you will have this social environment. All of these things will affect the performance of people that matters in the long run when we have accidents in these complex socio-technical systems. And I asked you if you had human-computer interaction. This is where I did my PhD, where you design something that interacts within one individual and the machine at a time. And you can have control rooms and all of these. And most likely during this week you have been in the right-hand side box. Jens Rasmussen was an electrical engineer that was very much interested in all of these various effects that, in the long run create risks in socio-technical systems. It is a long time ago, 1986, but we have read his paper, and today it is as valid as it was back then. So the system level structure is there, but on this system at various levels, there is a constant influence of environmental stressors. Whoever set the laws might change every 4 years or something, depending on the change in the political climate and public awareness. It is already at that level that conditions under which we work with safety and technology development actually may change. For the companies, there is a constant change in markets and financial pressure that we know. We saw the picture of the Deepwater Horizon, a perfect example of where they had started to build a very large safety management organization. They were working with training and recurrent training. They were really doing all they could in the possible functional parts for safety that they could, and the maintenance processes and their predictive maintenance and all that. But then there was bad years with very tough financial pressure, where production overtook the priority over safety, and they put things on ice, so to speak, for a few years to wait until we cannot, as I said, human factors cannot really prove things, and within risk management it's always difficult to say that this would not have happened if they continued their efforts for creating a safety management. But we had the accident, and yeah, so we can always be indicative and suggest that that was part of the contribution to that accident. You are now here at the summer school. You are doing what you can to change your competency, but we also at KTH, we train our engineers for the future. What level of education do people have that comes out into industry that will comply to rules and be the managers, etc. So it's fundamental environmental stressors, but they matter. And of course, why this is so still valid is that we have this fast pace of technological change that he stated in 1986. And compared today, it's, yeah, you probably wouldn't even call it fast pace back then. But we have in manufacturing industries, we have Industry 4.0 and all the aspects of cyber-physical systems that you have been discussing this week. And what happens is that this often comes in directly in operations. Companies apply new technology. So there's a lag in the system. It takes a while before things, the signals and incidents happen here, gets reported to the management and company level, where regulators will see that, oh, they are reporting events on this, what is going on? So this happens without the knowledge up here. It takes a while before things, risk information climbs in the system. In the same way, when you change something, it takes a while before it trickles down. And as I said, change is a difficult thing. I mentioned that there's a cross-disciplinary, because Rasmussen also identifies the difficulty, because we know from systems engineering that we need to be really good at working with both the software engineers, the mechanics, and so on. We are otherwise working in silos, and we're going to build things that don't fit together in the end. In the academic community, we also have silos, and we have knowledge built on the various levels. So those interested in how government are changing and working and how laws are produced probably study political science, economics, sociology, and law. And then we have economics, looking at societal needs of a financial sector, and organizational sociology and organizational theories. And then you start coming down to the companies, and that's the School of Industrial Engineering and Management acknowledged the need for engineering and management to coexist, and also in education and research. And then where I started out being a mechanical engineer, just picking on one of the over level of psychology, human factors, and human-machine interaction. And then we have the technology studies. There's, of course, no priority. It's just a system level. And it's the base of everything. So the top down and the bottom up, they affect each other. So it is a very dynamic, and it's a very complex system that develop risk over time, and eventually potentially ends up in catastrophes and accidents. What the Rasmussen's model does not show is that, of course, each organization, and there are tons of companies, and there are millions of employees and engineers working. So it doesn't really show the amount of heads and thinking and decisions going on here that affect the overall system. So if I were to mention one thing that safety management is, or what makes safety management function and work, it is if you can get feedback and support and a flow of risk information from those that knows anything about it, and the know-how is always with these people. The managers have an idea of what is going on. If they haven't worked themselves up, they might not hardly know what the engineering department is doing or what the safety department is doing. More looking upwards in the organization and facilitating quarterly reports and so on. But the staff and individuals, we have a long tradition in the Nordic countries and Northern Europe of flat hierarchies and very much engaging with our co-workers. But that doesn't look like that in all the companies. Many are still very hierarchical and demand people to do things without, getting their engagement and motivation from within. So within safety management, how many are working actively? You mean your students, but have been practicing the work of being an employee at a big company developing technology, or a small company? Half of you, yeah. In your work, have you had any reporting system for risk, and what kind of risk were you supposed to report?
But it was just like a red, amber, green.
Yep. And what happens after that? We had a colleague in patient safety. He had a no reporting campaign at the hospital here. And everyone was very curious. Why do you have a no reporting campaign? You're a human factors researcher. You know that nothing will ever be managed if you don't get the reports in, if you don't get people to say, here is something strange. Why do we have an iPad? This iPad doesn't work when I have gloves on. Why do people not bother to report? And now you're saying no reporting. The problem is that we don't usually get reports. But he just answered that we are not going to report one single incident until the managers have dealt with the 70,000 reports in the system that has not been dealt with. And that is what kills. Martin was suggesting, I was talking about safety culture, but the reporting culture and safety culture, if managers do not listen to what people say, it kills the reporting. And then you're blind. Then you will not know. And it takes like this to break that trust, and it takes years to build it up. So to get the risk information from individuals questioning, being critical to your work tools. Now I'm talking to you as the individuals, not necessarily the users or the operators of the technology that you develop, but also your tools might not be, up to date, and you might see risks in using that because you will end up in things that you don't want to be responsible for. And then you need to have processes for managing reports from various areas, from various units, and how you're supposed to categorize that. And we are using technology today to, of course, be able to data mine and see correlations and find relevant and aggregated intelligence. Because there might be one having a problem here and one having a problem here. And this one is dealing locally with these issues, and this manager is working locally with this issue. At companies that manage this very well, they raise it to a level where someone with expertise identifies that this and this and this have a common root, of course. Just as you were doing before, you have the bow tie or thinking in hierarchies and structures. But it needs to go also within the social processes and risk information. And then when someone have identified that this is probably a systemic error that all engineers need to be having a heads up, or all pilots needs to know, or at least everyone flying into Madrid needs to know, you need to have ways of informing people who has the need for this information, either companies, manager levels, or individual levels. Because organizations are in silos and in parts very isolated mostly, this is extremely hard to make it work. And there are many reasons to that, but I think that it's always difficult when you have a talk with a new perspective, because I didn't spend the hour to have that talk with myself before. But I'm just going to end with just a visual idea of how to understand how the company you're working with is contributing to a safe or an unsafe result. Many of you might have heard of Donald Norman, who wrote this book, Things That Make Us Smart, at San Diego, sorry. And I travestied him saying about technology, you can design and develop technology that makes us smart when it fits the way you think and so on. And if you don't, it makes you dumb, like the iPads on the child care ward. And the difference in the engineering is that you can improve and support the human abilities that you know if you know human knowledge, and you reduce the impact of human limitations. And this will be true also for autonomous systems, because someone will, in the end, before we have a fully autonomous society, there will be humans and managers operating and making decisions on also autonomous. So it's not, I'm just talking about these old human machine systems. And the whole idea is to reduce the design gap between the intended user and so on. Coming from my mechanical engineering and interface design, I brought this thinking with me to management. So we want to design management processes and structures that make the operations smart. And if we don't, the operations becomes dumb, and you will have errors in your work. So similarly, we need to understand how to strengthen these organizational capabilities for the sake of safety and also for sustainability and all these ilities. We did this training concept. It's not mind-blowing, but it works as a mental model of these issues. Because every day in a hospital or in airline operations and also in engineering work, you will have maybe a project-based management that, so you know that you will have a sprint and you will be very stressed today because you have a delivery tomorrow and you don't have time to work on these issues. And so there will be changes in your workload on day-to-day basis. And here is an organizational bridge where you are here. You will compensate when you're stressed. You will compensate when you don't have the right tools and everything. But you will mostly fix things because you want to. You are a well-intended person and you want to complete in time and you want to do it safely. It's not that you're reckless or anything. And this is the river of operations, which is the context that you're working under today. So there might be people sick, or you might be under extreme time pressure and so on. And when that happens, this river overflows and you will have to stretch. So let's say you have smart technology, you have a smart management and organization. So under normal conditions, you have the support to just make the little variations and the compensations to complete the work in normal operations. But when you have one of these days where everything is stressed and you have to compensate a lot, the organization and the culture, the reporting systems, the way they manage and handle your competence and your training, it can't be changed that day because it's the lag in the system. So more or less, the Lego pieces are going to be constant. So it is always the operator or the last link that will compensate. If you are in an organization that does not handle your reportings or does not train you in the new procedures or not think it's important that you know all the updates and what that does, along the line, you might find yourself that in a normal day you are compensating every day. This is very common in healthcare. I haven't heard anyone that says that this is their organization. This is the normal way of dealing with this. So when someone is sick or there's a trauma accident where you get 30 people in, or that you get a new order, or a customer calls in and says, it doesn't work and needs to work by noon. If you're in this kind of organization, the compensations you make is going to break. So I'm going to end with the concept of WIPIDO, which is well-intended people in dysfunctional organizations. And a lot of people who have been in organizations recognize themselves in this. We want to do a good job, but we don't always have the management support for this. And in safety management, these are the particular organizational functions that allows us to do a good and safe job. The other one is from Jim Reason. I think he put it very elegantly, that he says, we cannot change the humans, but we can change the conditions under which people work. And that's the engineering and the management disciplines job to do. Thank you for your attention. Comments, questions? I just run through this.
Analysis technique or a modeling concept that I should be looking at to get more understanding of human factors?
Yes, I could have a workshop on that too. But the work we've done, at least, I just have a very simplified picture. But this is kind of a model that we call system change and operational evaluation. It's just a model of depicting the stuff that goes on and the importance of coordination between people to understand the social processes. And the other one is that we do have a pretty thorough theoretical framework where we have identified things are not new per se. We know process modeling from manufacturing and process modeling in organizations and so on. But to use it in order to identify the people and what the competence the people have, who trusts who talks to who, in these silos, can you see who are actually supposed to be a team that doesn't consider themselves as a team because they are working in the risk analysis process together, but they sit in different departments. They're waiting for different reports or data analysis from that person, but they don't know each other, so they don't say, this is not really the figures I need, and they don't talk to that person. They just try to do their best with the report they get. And the people producing the report, they don't know who's going to use it and for what. So they just do what they are said to do to report this. So to get these social processes going, so the functionality of each and every of these management processes working as a team with relevant data and understanding who needs to be there in order to understand this data, and so it becomes information and perhaps also an organizational learning or knowledge. So this is the combining component. You have to identify a process for the function that is not working. If it's reporting or it's the risk management or whatever. And then you have to identify the people that needs to be in here or if there's lacking expertise and so on. And then you need to have this risk information reaching the relevant people and so on. So we have there are, we have the cube, but it's a systematic checklist review to go through and look through those social components and processes. So there are more to this. Not very well published because we have had EU projects and no time to write it up, but we are getting there, finally.
So again, the name was System Change, the scope was, what did it say?
System change and operation evaluation.
Okay.
It changes what scope stands for still. Yeah, but I can, you have my email from I can send you information.
Very nice. Thank you
You
very
know,
much, Pernilla.
don't know it's
You
semester.
will be here for lunch?
Yes.